I just realized I was talking on mute. Thank you so much for letting me know. And nice. But yeah, I can see already a lot of hackers from yesterday turning up. I hope you found the link yesterday, Mohammed, that you were looking for. Hi, Susmita. Welcome back. Thank you, Sohail, for turning up on time today. You too, Ali. Hi there, Krishna. All right. Well, I like a close knit group. That way I can answer more questions. And yeah, I am so glad you think so, Susmita, because today I have someone else joining me. I'm going to be more of a moderator today and more likely be learning on stream, which I apparently do better than actually teaching. So we're going to stick to that format for a while. Hi, Shubhangi. And Zainab's back. So is Sanskriti. All right, folks, are you all ready to meet the guest today? No, you don't want the guest. No, you don't want the guest. Is that a yes, Zainab? I'm going to be starting out today too. So you're going to be good. All right, folks, let me quickly bring up the guests so that you can have a quick intro of them. I'm pretty sure you already, most of y'all I can see in the stream might already know them, but just in case y'all don't, a quick intro, some social links so that y'all can keep in touch. And yep, y'all want a quick countdown or do you not want to do the drama? I'm okay either way. All right, drum rolls indeed. Do you all recognize this person? I'll be so happy to
Hello
hear a
there.
no. Oh, there's Susmita doing a countdown for us. I'm sorry, Susmita, there's always some kind of a
Did you
lag,
jump the
so.
gun?
Huh?
Did you jump the gun in terms of
I
the
did.
countdown?
I
Yeah.
I did. Thank you, Susmita. I like the efficiency here. So do you all know this person or do you all need an intro? Devin, do you want to go ahead and give an intro anyway?
Yeah, sure.
Oh, there's someone like guessing, are you a Dart expert? Which Dart though?
I mean, Dart is like a relatively very easy language to learn. So like Dart expert would not be a very um, high title, but yeah, I'm fine with that as well. So yeah, I am a Google developer expert for Flutter. If that like that's the closest thing to a Dart expert I can um, point out. But yeah, so primarily, okay. So my name is Evan. I work in an organization called Stream. I work in a DevRel capacity in Stream, whereas I also worked in engineering roles before at Stream and in other companies. I am a Google developer expert for Flutter. I do technical writing, speaking, a whole bunch of stuff, mainly related to Flutter and Dart. And yeah, so with regards to Flutter and Dart, I started out very, very early on, like in the alpha-ish stage of Flutter, and Dart back in maybe 2013, 2014 was the first time I ever tried it. So yeah, I mean, I really, really do like Dart quite a bit because it's a very nice, very easy language to learn. And like more recently, it has been adding more and more of the beloved features of other languages. So yeah, I mean, pretty like fond of Dart. In terms of Flutter, doing it quite a bit. You may have seen, like, if you've ever learned Flutter, maybe you've seen any of my Medium posts or stuff like that. So I used to post a lot on Medium. More recently, just getting up to speed in terms of like the technical community is back. Talking is like public, in-person conferences and events are back. So yeah, just going and meeting a lot of the folks whom we've missed out meeting for the last 2 years maybe. And yeah, so Flutter has grown to quite a large extent. And initially you have these kinds of, let's say, example apps, right? You have these to-dos, you have these to-do apps, or you have just the basic kinds of apps that kind of grow up in a very nascent kind of code base. Then later on, as the framework matures, what eventually happens is that you kind of get bigger and bigger questions, and like how do you make bigger and bigger apps. And now later on it comes to a phase where you can do fun things with the framework, right? Like if you look at JavaScript today, you may find a lot of things like P3, or like just a bunch of stuff that may help you do creative stuff, not just necessarily like something you have to do for work. And similarly, now Flutter is coming to it's coming to a point where it has genuine, like obviously it's a much like it's a very maturing framework, but now it's also getting a lot of creative uses. And it's I'm glad to be part of that as well. Okay, so just to give you an idea of Flutter, if you do not know anything at all. So Flutter overall is a cross-platform. Okay, framework is a very loosely defined terms in a lot of cases. Let's just call it a framework, but keep in mind it's more of a UI toolkit. Okay, so I'll use framework, but whenever I say framework, replace it with UI toolkit. So Flutter is a cross-platform app development framework in which essentially initially it started out with just Android and iOS, right? Initially it's just started out with how can we develop apps for both Android and iOS at the same time. And later on, there was not later on, initially it was kind of developed with the idea that we're doing it in a very different way to what other frameworks like React Native and those things were doing. And because of that, suddenly it was very easy really to port to web, to port to Windows, Mac OS, Linux, and just a bunch of stuff. And because of that, what's effectively happened now is that you have these, like, you have a framework which can run single code base on 6 or 7 platforms, and that is immense power. Like, it just, like, just imagine writing a single bit of code and then running it across like everything. And I think somebody said something about Google I/O, and I'm not sure if it was Google I/O like a few years ago or it was something else, but there was one event in which they did like the Flutter Octopus. And the Flutter Octopus was essentially like, just a bit of Flutter code, and they actually connected like 8 devices and ran the same app across, like, all the possible frameworks. And that was pretty cool. And also recently, like, even more like solid companies have started supporting Flutter as a whole. Microsoft is a very closely associated one. If you know Ubuntu, Canonical wrote the Ubuntu installer in Flutter. Toyota is doing a lot of stuff with writing their car dashboard stuff and stuff like that. Philips is doing a lot of work. So Google Pay is now written in Flutter. So just a bunch of big companies are being just porting Flutter, sorry, their native Android apps or iOS apps to Flutter, mainly because suddenly you do not need multiple code bases anymore. You don't need to have uneven feature parity, across across platforms, and you can just write one thing and go with it. Obviously, it's not going to be the absolute perfect fit for everything, in the sense that there was some time I also do, like, some things. Let's say I did a project on GPS and stuff, and that is obviously more technical, but technical meaning like low level rather than something that is cross platform essentially. But even then you can still, write native code, you can still do a lot of stuff, but again, like, obviously not the perfect fit for absolutely everything, but honestly a really good option for a lot of things overall. So yeah, that is Flutter. Recently it's launched its 3.0, and yeah, the 3.0, I mean, it kind of shows signs of it being a maturing framework now. So that is an overall intro to Flutter. Let me know if you need something else that is more specific, companies, technology, feature parity, whatever. But yeah, that's more or less it.
All right, that was a pretty great intro. But the offer remains the same for all the hackers joining in the stream. If you all want to hop onto the stream and ask questions, you know the drill. Go on Discord, create a ticket, tag me, and I'll share you the stream link. Apart from that, there are a couple of ways we can go about the entire setup today. We can first dive into the technical part, actual Flutter part, and let Devin run the entire tutorial. Or we can do it completely hands-on, where I do the installation because I'm the only person here who might not have Flutter, so I could run the entire installation, and then Devin can take it over from there and show you the actual tutorial. How would you all want to go about it? Do you all plan to follow along right now? Do you all plan to just watch the stream and then follow along later, so we accordingly make sure that it's worth your time? I don't see any comments regarding any of the options yet, so we're gonna wait on that, and I'm gonna keep an eye on Discord in case you all want to hop into the stream and ask Devin any questions. Devin, do you have a preference until then? Follow along later. So do you want to make sense? So how about I let then Devin start his tutorial. He'll probably explain the entire setup, how you start a new project preferably. And yeah, all right. Seems like everyone has a consensus here. Great. So yeah,
So I'm
Devin, do you want
confused.
to
Follow along meaning following me or follow along you with the installation?
No, they will watch the tutorial later to follow along. So it makes sense that you explain what you're going to explain and show them what you're going to do without really taking into consideration except anything except questions, technical questions, and then they'll pause and follow along the steps later. Oh wow, Himanshu came prepared.
Okay, so you want us to get started with Flutter directly, or like, so no,
Yes.
you're not showing installation right now.
No. In case
Okay.
anyone wants it in the end, we'll do that because no one's following
Okay.
along
Perfect.
right now.
Okay. Okay. Sounds good. All right. Um.
You
Let me
ready?
just, I have two different screens to share because I forgot to show like any of my profiles in the introduction. So I'll just like do that quick bit.
Oh yeah, that makes sense. So first we'll just have a little show off from Devin, and then we can get started with the
I like how
actual.
she phrased it, but okay, thanks. Okay, so is my
There
screen
is a
visible?
quick question. I'm not sure whether it's for Flutter or just generally. I think there is something called GitHub Code, which code spaces by GitHub that you all can try using. And there's something called github.dev. Have you all tried that? GitHub.dev is basically GitHub's entire code editor, and you get all VS Code functionality. Uh, yes. So Salman, I think I can't pronounce your username, but that's what Devin will be showing right now when he shares his screen. And Susmita, this is for you. I will also post the link in the chat as well so that you can follow along. All right, Devin, back to you.
Yeah, sure. I think there's a bunch of thing, and I'm not sure exactly what they're referring to, but just like I'm not sure, like you may be able to follow along, but I'm not sure. So there is no VS Code thing particularly. There is something which I can't tell you at the moment, but which is very exciting, which will come up soon. But rather than that, there's also Dartpad, Dartpad.dev. I'm just going to Google Dartpad and see what happens.
Hi, Siddharth. Feel free to drop into the stream.
Ooh, I realized hang on, my other screen is on the. Yeah. So hang on, this is Dart.dev. This may be it. Okay, so you can, if you really want to like just, I don't know if you can follow along that quickly, but at the same time, if you just want to run something or the other, you can go to .pad or .lang.org and kind of follow along with this thing, because we will not have any dependencies per se.
Two questions, Devin. One, can you see the StreamYard screen right now?
Yes.
Okay, so there's a question on the screen for you. And secondly, can you post the links to me? I'll keep sharing them.
All right.
Quick answer, Dortico. That was only for anyone who was trying to set up VS Code locally. You can, I'm not sure if you can install Flutter onto any other server, but you can give it a shot. The installation should remain the same on github.dev.
Yeah, and in this case, you can just basically select a Flutter one, and then you can run the entire thing for output. Again, auto completion not amazing, but at the same time, I mean, not bad either.
And Jasmita, Calitris answered the question for you. So try running Flutter in VS Code, not in Android Studio.
So by the way, this runs like on the web. So this is Flutter for the web directly. And the funny thing is, how Flutter checks if it is on the web or if it is not on the web, is that this runs a JavaScript compiler, and normally it runs something else entirely. So what happens is that it simply checks, uh, is 0 equal to 0.0. That is what it checks. So if the two are the same, then it is JavaScript. If they're not the same, then it's like Dart or whatever, like like proper compilation through other languages. So that's how it's differentiates in the compiler, that okay, what is this actually running on, and that's really fun. Okay, so that is what you can like actually run it on if you are interested, and if you don't have Flutter running, or it's like or if you do really want to just test something out, that's fine. So I'll also just guide you through the Android Studio project, and I don't think like VS Code should be that much different. All right. So just before that, this is like my Twitter thing. You can also see like a generative art background that I made. Usually, from that, there's like some posters and stuff like just there, which I also make through generative art. Yeah, like post like a lot of experiments on Twitter. I'm not exactly sure like how far I'll have to go down. There's I have a Medium page which I write a lot on, essentially with respect to like Flutter. I'm a big chess player, so like I love adding chess to whatever I get. And yeah, I'm just animation, generative art. Like I wrote an article about that as well, so I do a lot of Medium stuff. I also finally have an Instagram page about generative art uh, directly. Um, so yeah, we're gonna go through like these are some of the examples. I'm not logged in currently, so like let's not. But yeah, like these are some of the examples. Hopefully, you can see good enough like this just through generative art. And the funny thing is about generative art, I I'm not a person who's very good with like colors and like designs like that, but I'm somebody who likes math a lot. So in a sense, I don't really like doing like deciding colors and stuff like that. I like to let the intricacy of math itself come out rather than actually going and doing something ourselves, because in a sense then you're discovering something, you're not really creating it. And that's like for me that's much more beautiful. So yeah, like these are the kinds of things I used to make. There was like a lot of variations of the Mandelbrot set and stuff like that. So a bunch of stuff. Maybe we'll go into one of these today at some point. And yeah, like I also have a code pen in which I do stuff. Maybe I'll explain this code a bit later. We can take it on after I explain just the basic stuff. um, it may take some time to load, but hopefully we can get it to actually run. But yeah, so that is the overall thing. Yeah, so this is as an example. um, Fractals are the prettiest type of art. So fractals in a like the thing is fractals can be drawn in like in a lot of different ways. And let's say as an example, not exactly I mean kind of a fractal, but like uh, I did a bunch of the Mandelbrot sets on Twitter. And okay, let's see if I can find the Mandelbrot set thing. But I did a bunch of the Mandelbrot set things, a lot of experiments with that. And with Mandelbrot sets, yeah. So for example, this was something I just used to like generate the same thing. And hopefully I can get the Mandelbrot set, but because that was really, really beautiful. And yeah, okay. Found it, I think. But I'll explain how this comes and like how these things work. But like it just like this is not an overlay. This is just very simple Mandelbrot drawing code, and you just change how the fractal is rendered in a sense. And again, like even like with this one, if you read about the Mandelbrot set, that's great. If not, I really recommend check it out. And yeah, like there is like this checkerboardish pattern, nothing at all. I did nothing. This is not an overlay of any kind. This is not me making it fancy. This is purely drawn from an equation. Maybe I'll have to code for it, maybe we'll get to see, but let's see. um yeah, I mean like the red ones and like just how they connect, and it's all like really pretty. So yeah, like there's like a whole bunch of Mandelbrot set. This one I made Minecraft, so let's let that go. But yeah, like I love doing like fractals are beautiful because they're directly in math, right? Like in a sense, you're not really creating it. Or checkerboard pattern equals chess. Okay, yeah. I did not see that coincidence, but yeah, fair enough. Yeah. So this is the trigonometric thing. Was something that we can run through the code. But before that, I just want to kind of show you like just the setup overall. And maybe like we'll try to draw a simple spiral, just like try to draw a simple spiral, see if we can do something with it, alter colors and this and that. So we'll go towards a more like in a sense purposeful way of drawing artistic stuff. But then we'll kind of see if we can make any modifications to it. I have not prepared anything because I really want just to see how we can do that, and maybe we'll use some of your own ideas as to how we can modify it and make it look prettier, how we can maybe layer it and that kind of stuff. So I'll explain the basic principles of how I do generative art in a bit, but before that, like let's get like a canvas ready for Flutter. So let's first create a Flutter project and then go into maybe just actually understanding the principles of generative art that I use, and then maybe creating one of these. So yes, we do use Custom Painter, and Custom Painter is so okay. Just to give you some kind of a background, almost every, or every rather, framework or even an OS has something called a canvas. A canvas is what we use to actually paint pixels on, in a sense. And you may have done these in, if you're still in college, you may have done these in your, your computer graphics labs. If you're out of college, I mean, you still will probably use it in maybe like, OpenGL, WebGL kind of interfaces, stuff like that. So there's a whole bunch of stuff we can do with canvases. I prefer doing this, obviously, but at the same time, underneath it is all rendered on canvases. So the custom painter or custom paint widget is the actual thing that does the rendering in Flutter, right? So that is the overall um, rendering engine, in a sense, like the rendering background that we use. But yeah, so could a randomized start point function be made some username or something like? Yeah, absolutely, absolutely. But again, like, see, look, that implies like you'll have to make the you'll have to make the generative function like that, right? Like you have to make something that is dependent on that randomness. What I mean is, obviously you could always randomize something or the other, and I actually remember doing like this function chaining in a sense that I like changed a lot of functions and then kind of like modified it based on the like username as a generator or hash or whatever. But in the sense that some random functions aren't as effective as generating stuff, and you have to make sure that whatever you're like, when you say usernames per se are not really, I'm assuming you'll convert a username into like some kind of binary or like some key which you will use as the generator function for the randomness, right? So in that case, yes, you can definitely use it, but you kind of have to check the efficacy, in a sense, of the username or the number as to how much it will modify the end diagram. So yes, in some cases, if it is based on that randomness, if that randomness function actually affects the final diagram quite a bit, yes, absolutely. If not, I mean, pretty fine. Like, nothing big either way. So like, obviously you'll have a more static diagram, but it might still be pretty, right? So yeah, absolutely can be done. But yeah, let's see. Okay, so before like we kind of get into, I really want to explain like, how I think of generative art. And obviously, like, these are more like, this is more as to what you could call pixel art, rather than not pixel art, but like, in the sense that I'm drawing dots rather than actually painting flows or something like that. And that is also something you can do, but I don't prefer that because I just want to get the intricacy of the mathematical functions out. I don't really care about making fancy flows and stuff, right? Okay, so by coding a Dartpad and not installing Flutter for now, yes, you can. The thing is, like, if you just copy that CodePen thing on Dartpad, I'm not sure how much time it'll take to run. Um, it could run. I have not tested it out. It could be quick. It may not be quick, because the thing is, if you look at that thing, if you actually look at the code, there's a whole bunch of iterations. And just FYI, I did this more for my own recreation. I did not do this in any senses for efficiency of any kind. So a lot of numbers here may be unnecessary, or I might be drawing like 10 times the width of this canvas. I absolutely might be. So I'm not saying it's efficient, I'm saying it's good. So yeah, you could run this because it has no dependencies. Just try and run this. If it takes a lot of time, then I would just suggest this number, like, with this 1,000 number, just drag it down a bit, or just make this 0.1 or something like that. So just like, so you don't need that many iterations, because this in itself is a recursive function somewhere. Yeah. And also it's drawing a lot of points. So yeah, like, as you can see, it's not necessarily computationally um efficient. But yeah, like, could you probably make it efficient? Yes. Have I done it? No. But yeah, I mean, I would please read through like, some comments or something, like, I've like given, we will come to this later as well. I want to like help, I want to actually drag this into our own code and modify this. But for now, let's kind of start with a spiral, like a just normal spiral, kind of get the feel of how canvases work, how Flutter works, and then we can get to actual generative art, right? And after that, even if you just start with this source code, you are good, because you know how Flutter works, what you need to do to modify this, right? So yeah, it took less than 5 seconds to load. Okay, that's fine. I mean, that's great. If it does, that's good. If it doesn't, then yeah, because I have not tested that. And Dartpad is improving over time. So like earlier it was very, very slow. Right now it works pretty good, pretty well. So yeah, definitely try. If it works, definitely try it out. Okay, so I'll just go. Hang on, I might have to share a different screen because I need my bigger screen for doing the coding. So just give me 1 second.
I can see a lot of enthusiasm here, which is pretty awesome.
Hang on 1 second. Sorry, I'm just gonna like change over the screens a bit. I'm gonna drag all the content from the small one to the big one.
Yes, it's lucky we know that I don't have two screens because one screen I can barely handle with 100 tabs. So hopefully next time you'll see me struggling more. Let's see.
I don't understand why you need more than 10. Like, is it that much cognitive overhead to just remember what you need to do or
In
to do
my
a list?
defense, even those, well, let's go for a safer number and say 200 tabs, are well organized. Okay, they have groups. It's just then I forget what I called the group for.
Nice.
Yes, a minimum 100 tabs. I would have shown my screen had I did not have Office stuff open, but someday you all will
Sure,
see.
sure. You're not showing it to us because of office stuff, not because of the clutter.
You know what? I'll show it to you if you all understand, and if there's something that goes, we'll just delete the stream. Also, folks, feel free to tweet about this. Oh
Yeah,
yes, that
yeah.
is
What
true. So,
is your RAM capacity?
so this laptop has 8 GB, and this does not hang up. The other laptop, the laptop I use personally, has 20 GB RAM and still manages to hang up with two Chrome windows open. Again, a lot of tabs. I agree, but still
Okay, 8 GB.
very impressive. I know I could do marketing for the laptop at this point.
Fair enough.
Good idea. I will do that after the stream.
Okay then. Okay, so I use like stepping away from the nightmare Chrome tab situation, like just going to Android Studio for a bit. So just understanding, like, so if you want to get started with Flutter and Android Studio, just follow along the steps. But at the end of the steps, you will also have to install a Flutter and Dart plugin in Android Studio. So install that, and then you will get the option to like create directly a Flutter project. So this is what they look like. Notice that it also has these additional platforms. Like, obviously, I mean, it's weird that we can actually open an iOS simulator with Android Studio. But the point here is, like, you have all these platforms, which is Android, iOS, Linux, Mac OS, web, and Windows. I haven't enabled them, but regardless, like, I like web, to be honest, is a more kind of nascent thing, so don't use it for production is my advice. But Mac OS and Windows are coming along surprisingly well. Even Linux, I haven't tried, that's why I'm not saying that. But Mac OS, I have tried and I love. I mean, honestly, it has come the farthest, and a lot of people are using it directly to create production apps, and it's working quite well and very performant. So yeah, so I can select, run this in web, run this in Android iOS. For now, I'll keep Android iOS because I don't necessarily want to run this in web, and it doesn't require any extra setup per se. It's just like, you can just select and you're good to go. So for now, I'll just give it a random name. So let's say Janart Stream. And yeah, so there's also some other stuff which you can create a plugin is like, if you want to create some native code, meaning if your plugin, sorry, hang on. So a package is essentially a dependency, right? So if you want to create a dependency, if you're going to create a library, also called a package in Flutter, uh you would use a package. But at the same time, if that package contains some native code, then you use a plugin. A plugin is a package, but with like some essentially platform channels to get or execute code in native format. So Android code, or like, Kotlin code, Java code, or iOS code, stuff like that. So, Swift or Kotlin code could easily be run even in a Flutter application. So that's a plugin. A package is a library, but only simple pure Dart. A module skeleton I've never used, so I have no clue. So yeah, you can specify the native language of Android and iOS. So for example, you can use native code if you needed to, and that, again, you would write it as easily as you would do it on Android. You would just need to call it from Flutter, and then like just make sure the data types match up. So yeah, so let's create this. So what I'll do is I can directly run, oh, sorry, here. I can directly open like an iOS simulator from Android Studio. And now there's only like a few important things. So the only three, maybe two files that you need to remember are pubspec. So pubspec, you add your dependencies and stuff like that. We are not going to add any, but you can add your dependencies here. You can add any assets and stuff here, and versions of the app, stuff like that. So pubspec is like a configuration file for your app. The lib directory is more of where your code lies. So that is your main dot dot, just your main function and then your app, like pretty simple to understand. And then there's your Android and iOS, like native folder. So if you, let's say you want to do something that um, does Android, let's say you want to change the manifest, because you still need to declare the permissions and stuff like that in manifest, you can just access that directly. So I used to be an Android developer, and yeah, it still carries along some PTSD. So yeah, I mean like we were relatively good. So yeah, iOS is the full project, and yeah, you can run the whole thing. So these are your native underlying things, and if you're wondering, these things just have a canvas inside them, so they just use the canvas and then they let Flutter do the all the other stuff. So main.dart is our main class. If you let's actually running this. Again, it runs everything. You might even see Mac OS. If you can see Chrome if you want to run web. I don't have that right now here, so it won't run, but it would be really cool. Like just imagine writing an application and running it across, just creating just a DMG or something like that. So also another feature I really like is hot reload, like web has. But the thing is, initially, the absolute first time you run an app, you will still need to do some, like, you still have to build a proper build, right? So let's say an IPA for iOS and an APK for Android. So you would still have to do the Gradle build or an Xcode build here. But once this is built, then they just like Flutter just directly uses code injection. So essentially, look at this. Yeah, so it is the default counter app. It's like the hello world thing for Flutter. And let's say I want to change the color of this. So it's the background color here. Let's say I want to make it, I don't know, black or blue gray, let's say. So this is the button, and I want to make it blue gray. I hot reload and it's done. Like, there is no excessive build time and stuff like that. And it's just very quick. If I just want to remove this altogether, I can do that. It's gone. It even does like this default animation. Like, it doesn't just remove it. It actually removes it as if it would be removed in an app with an animation. So that's pretty cool. If I insert it again, it's popped into existence. So it's quite nice. You get to do all of this. And again, if you change something, let's say I have another class here that won't necessarily show up in the hot reload. It might, I'm not sure. But point is, you can just do hot restart, and again, it barely takes 200 milliseconds here, even in the fully built app, 1 or 2 seconds at best, not more than that. And because of that, it's pretty cool. And again, if you're from Java, yes, you can declare multiple classes in one app. Know your your class does not have to be the same name as your file. A lot of nice stuff in Dart. So let's kind of look at the overall thing. So I just want to give you like a basic idea of essentially how Flutter runs, or how the basic file is structured. We're not going to deal with multiple files. We're not going to deal with any dependencies. So we only want to study what is in this file, and then we'll go from there and add our canvas and then get started with generative art overall. So first of all, material. If you've ever heard of the material standard format, I don't know what it's called, but I think it's called a design system. If you've ever heard of that, it came along with, like, what, Lollipop 5.0. So it is Google's standard for, all these components, Google's design for everything. So let's say, the app bars, the floating action buttons, more or less, like, these are designed with, like, elevation hovering above the main, like, this thing, like the background. So all of this is a design spec given by material. But if you want to design purely for Apple and you really want to adhere to everything Apple does, there's also a Cupertino are all the Apple components and stuff like that. And again, you can still use Apple components without, while still using the material navigation and stuff like that. But at the same time, I mean, most of everybody uses material. Cupertino, honestly, I haven't seen very many apps use Cupertino directly a lot, but it is a complete system, so you can do it if you wanted to. Second, the main function. I think it's pretty obvious. It's just a normal generic main function, and it has a global function called run app, which just runs this thing. Whatever it is for now, let's just let it be. So my app is the app. And again, if you notice, this doesn't extend something like an app or something like that. It just extends a stateless widget. So in Flutter, everything is a widget. That is a quote that is on multiple t-shirts. That's a quote on so many things. Basically, the quote here is everything is a widget. So essentially what that means is Flutter aggressively uses composition, and everything is like a block that fits inside the other. And this makes it very easy to make interchangeable components. So an app itself is the same type as, a button or something like that. So I could have directly added a button here and stuff like that. And I'll show you that as well. Maybe we'll do like some generative UI. I remember doing that once, but I'll give you that example later. So yeah, so what is a stateless widget? Um, the basic distinction should be clear. A stateless widget is something that does not have state. A stateful widget is something that does. Now, what is state, right? State is any, in a sense, mutable data. Let's say, as an example, the counter app, like if there's a counter, then this count has to be stored. But we don't really need to actually understand, anything else. Like, as in, this text does not change, this counter does not, like, this button does not change, but the counter value does. So the counter value is the mutable data. Okay, sorry. Project app tree. Sorry, yeah. Sorry. What's the app tree exactly? I'm not sure.
I think he means the project structure. Is that what you're asking, Tintin Tikaya?
So just clarifying, are you about a project structure, or are you asking about something specific in the project structure? Or are you asking about, like, the different trees, like the render tree or the widget tree?
It takes a while to get the streams and comments in sync, but until he replies, you can continue.
Okay. If that is what you mean, in terms of how do widgets branch, yes, the entire, so what we call it is a widget tree. So let's say the very top is the my app, and it kind of goes into these smaller things. So let's say my app has this thing, like, this screen. This screen has this app bar, this background, this text, and a floating action button. So it's like, at the very top you have the my app widget, and underneath it, like, you have a tree, which, like, basic, that is the top of the tree. And then you have all these components, which can, each of which can have multiple components. So that's how the widget tree is composed, and here we are building it in a sense. So I'll just remove all the comments because it makes stuff quite um complicated for people who seeing it for the first time. There's too many comments and too little code, and that's why, like, it's very easy to think, oh, that's so much code. Okay, I think this should be better. So first of all, this is the app. Now, if you look, we're returning a material app, and similar to the material app, we also have Cupertino app if you want to do a complete iOS like thing. But again, even an iOS app can be a material app. It's just about the design system. um the title is in a different place. Like, okay, let's let that be for now. Theming is relatively easy, and since it is a tree, this theme is now inherited by each further child of the tree, for every widget. So whatever it is, let's say I want to have a background color of, um, or maybe I might have to set a scaffold background. Yeah, let's say I want a blue, like, I want a different background color for this scaffold. I'll explain what a scaffold is a bit, but automatically you can see, this is not how you necessarily need to change this color, but you can also do it through theming, so that every single scaffold, in the a scaffold is like a page for now. Every single scaffold in the app will be now blue gray. So, and now what is the home page? It is the my home page. Like, whatever this is for now, this is the home page. So now it's like relatively easy. This is just the app setup in a sense. Again, theming just applies an overall theme to the app. Home, what is my home page, right? Now, this is the actual home page. Now, notice one thing, it is now a stateful widget because it actually has data that we need to store. What is that data? This counter value. Other than that, this is what this you have pushed this button line is something we've already defined. This how this like this button looks, we've already defined. How this app bar looks, all defined. And because of that, now we have this counter data that we need to store, and you can simply see it declared as int counter is equal to 0. Should I increase the font size preferably?
Yep, that would be good.
Sorry.
Yeah, that would be nice. Maybe a tad bit more. Folks, feel free to comment if you all need it to be smaller or bigger, for that matter.
More.
No, we're good. I think this is good for me, but if anyone else has a preference, let us know.
So yeah, so the counter value is it's just a simple variable, which is an integer, and for now it's 0. And then every time we increment the counter, it's just counter plus plus. If you notice, like, there may be an obvious question: why is there a, like, the thing is, um, so if I just wrote counter, this is still valid, uh, but the thing is, this is a public variable. So there is no public, private, anything. So, like, there is no public, protected, anything. Public is just not a keyword. If you add an underscore, it becomes a private variable. So since I really want to save this thing into the class itself, I don't really need to. I should really do an underscore. But if I don't, it's still fine. There's nothing. It won't change anything. But that means, compared to Java programs, a Flutter program is much smaller, like leagues smaller, like in a sense of verbosity, not in the sense of size, um, and also size, to be honest. But point is, there is, like Java, you don't need to do anything like, static is a keyword, but, like, public, static, whatever, public and stuff just isn't something that you need to be worried about. And also, var is a keyword, so basically you don't really need to define integer either. It will automatically take it as the integer. It won't take it a dynamic value or something like that. You may say, okay, but var is also there in Java and stuff like that. Not really. I mean, var in Java is kind of a joke. But yeah, I mean, it's a very limited kind of definition of var. Whereas in, JavaScript and, like, a lot of other languages, at least it's, like, relatively complete. But since Dart it has a sound type system, even if you say var, it will be still given a integer value. It won't be given some other value or a dynamic or an object type. So yeah, that's the so integer declaration. So sorry, variable declaration, pretty much the same. You can use int, and this is one thing I really love about Flutter. It gives you the option. If you like integer, like if you like saying int, do it. If you like saying var, do it. If you want to declare something, if you were doing this in Java, as for now, just assume this is a class, and it is a class. But you would have to obviously write a new keyword. And again, new is still a keyword here, but but like it's unnecessary. You do not need a new keyword to declare to instantiate an object. You can just do it. But again, you have a choice. If you want to have it, you can. And const is the same, stuff like that. Okay, so now let's actually get into the code. For now, I'll just delete this entire thing so you'll understand a bit better. It is a bit like Python. It's actually very Pythonic. As an example, if a list is just simply a declaration like this, so it's effectively a Pythonic list. So you have a very easy list. You have your normal list functions. What I like about Dart slightly over Python, to be honest, is for example, anonymous functions. And anonymous functions are amazing in Dart, whereas they're very confusing to me in Python, and they're downright unreadable to me in Swift. So Python, if you're doing Lambda functions, maybe what you call it, slightly different definition, but let's go with that. So Lambda or anonymous functions in Python are confusing to me. But in Dart, they're very easy to read, and we'll go with, and maybe I'll show you as well. So as an example, let's say I want to do let's do an anonymous function. Let's say I want to print every element of the list. I have a for each, and I can just do, let's say for each element of the list, I can just print e. So essentially what's happening again, sorry. So essentially for each element of the list, I can basically just print e. But there is an additional amazing thing I can do. Again, I don't even need to define this, since for each wants a function and print is a function which accepts anything. I can just literally say print. Now again, this is, to me, I like it. For each element of the list, print it. I don't there's no function. I don't need to say invoke the function. It'll automatically invoke the entire thing. And this is amazing to me. In Python, at least from what I've seen or done in Python, it's not as easy. And it's a very weird, you have to do a very weird Lambda declaration for that. So yeah, for me, Pythonic, yes, in some cases. And again, obviously Python has significant advantages in other areas, especially in terms of long-term processing. But honestly, in terms of UI syntax, I like this a million times better. Going back a bit because I can talk about Dart way too much. Okay. So a scaffold, imagine, is like a page. Okay. It's not essentially, if you imagine scaffolding, right? If you imagine a scaffold, it's a structure. It's not necessarily a page, but it's a page structure. So it supplies essentially places for all these things to go. For example, you see an app bar. An app bar can realistically be anywhere, right? An app bar can be absolutely anywhere. But the scaffold tells it, okay, if you give me an app bar, it will go here. If you give me a body, it will go in the middle. If you give me a floating action button, it will go over here. But again, it also supplies some customization. So I think, yeah, it also has a floating action button location, which I can just change. Let's say I want to center float the button. It'll go in a different place. So point is, it does provide some customization, but in general, it gives us where is the location going. And like I said, everything is a widget. So an app bar itself, this app bar over here, is equivalent to something else. An app bar itself is equivalent to the text. It's equivalent to the button. So I could have a button in place of the app bar. But here's something I will show. This is a page, right? This is a page. The scaffold defines a page, and the elements of that we've defined inside, let's say the app bar, the body, the floating action button, are elements of that page. So instead, let's remove this 5 and just add the page back in. Let's hope this works. Oh yeah, sorry. I need to give it some kind of size, or else it's just gonna overflow. I can, again, bad implementation, but the point is valid. In a sense that, look at this. This is like a mini page inside the bigger page because it is all interchangeable. It's all basically Lego blocks. The point here is I can have a mini page inside the main page because everything is interchangeable. Everything is a widget. So everything can go again with itself, and it can become a very recursive thing if you wanted to. So let's just kind of go back a bit. Okay. And also, if you've come from other languages, it also has string interpolation, which means that if I want to do just add the counter value, I don't need to do counter to string or something like that. Or if I wanted to say count value is, I don't need to do the plus string or whatever. I can just do a dollar sign, which essentially takes the value of the variable we declared and just adds it to the string, which is very, very convenient. And it has multi-line strings, stuff like that. So basically, Dart itself, very useful thing. But okay, so the point overall here is that these are all widgets, and we are basically going to use none of these. So we'll delete the whole thing. At least we'll keep the scaffold because it gives us proper sizing and stuff. So now we have a blank canvas, and maybe we'll add an app bar just so we have some. Never mind, it'll look bad. Yeah, so we'll just go to a body, and now we need to add a canvas. So how do you add a canvas? So we first use a custom paint. And the size here is undefined, so I'll just do like, I'll just give it a like size. I'll add a size box as a child, so I'm not really adding anything as such. I'm just giving it a size, to be honest. I want to add a child. I know I'm adding an infinite size, but it doesn't actually take an infinite size, so don't worry about that. Actually, hang on, I hope not. We're good. Now, okay, so this is just a setup of the custom paint, and now we actually need to define a painter. A painter is what will tell the custom paint what am I supposed to paint at all. So the painter, and for that we need to define a painter, which will be a class, by the way. So let's say demo painter, which will extend custom painter. I'm doing this off the top of my head, so if I mess something up, please be a bit sympathetic. But so for now, we'll just give that instance of the demo painter. Okay, so now forget everything else. We've set up a canvas. I will just remove this counter variable, which we don't need anymore. We've set up a canvas. We've given it a size, which just fills the whole screen. And we've given it the painter. Now forget the whole thing about. So this is the only thing we need to be concerned about. The demo painter is the thing that actually paints something on the screen. It has two main variables, paint and should repaint. So should repaint will just say false. So should repaint essentially is what? Should repaint means, let's say we're accepting some data into this. As an example, somebody said before that what if we use a username to generate this art, right? So if the username changes, we should really repaint whatever the diagram is. So if in that case the data changes, yes, we should repaint. So the point is, this function is something like that. If you define when the entire diagram should be repainted, and in the paint, you actually paint. So for now, let's do the computer graphics 101 thing. Let's paint a circle. Okay, hang on. Before that, there's an object called paint. Paint meaning, let's imagine it as literal paint, right? It has some color. It has not literal paint now, but like it may have, imagine a stroke of paint, rather. Imagine a brush and the paint, right? So a brush will have some stroke width. It'll have some color you actually dip it in. So let's say first, let's define a color. Let's say I want a blue paint, and I want the stroke width to be 10. 10 will be very large, but let's say 5. So this defines the color and the size. And now we can actually draw something. Let's say I want to draw a circle. Where do I want to draw a circle? How large do I want to draw a circle? And what is the paint I want to use when drawing a circle? For now, the stroke would be absolutely useless, but I'll show you where it's used. Let's say I want to draw a circle with radius 50. And I want to draw it at the point 200, 200. That weirdly came out quite perfectly in the center. But yeah, so this is the basic idea of how we work with paint, like how we work with canvases. For now, ignore everything else. This is what we're working with. This is the paint function is the only thing we really want to see, and everything else is kind of pointless. So After spending quite a long time explaining that, I understand, but yeah, you kind of need to know that to actually modify a lot of stuff. I'm not sure exactly. Oh yeah. So point is, with draw circle, you have a bunch of stuff. Let's say you can draw a whole bunch of stuff. Let's say you want to draw a circle. You want to draw vertices, shadows, ovals, lines. You can even do like very fancy Bezier curves and stuff like that. Like out of the scope for right now, but you can. And yeah, so if you actually want to do something yourself, in the sense that, to me, generative art is more about mathematical patterns than your own. Meaning, in the sense that you could do some like nice layering and stuff like that, but if you actually want to paint something, right, just the generic house and mountains and a river, then you're doing it in a purposeful way. So you're doing it by yourself. So you're defining a lot of these squares and circles and stuff like that. But why I don't use curves a lot is because that is a more purposeful thing. And maybe in some fancy things you could do it, but I like just doing pixels. So point is, for the entire uh um more or less the entire thing, just going to be using this one function so that we have it easier. And we'll make the radius much smaller, because like five, like we want to make these like pretty small. And let's go from here. Okay, so now, to me, what are the so how do we go with generative art, right? How do we go ahead with creating something? And I'm going to tell you straight away that most of it will feel like an accident, like, you don't deserve any credit. The reason is that this is not something that is very obviously defined, in the sense that if you want to find a new pattern, you have to kind of do a lot of trial and error. You have to see what functions work. And also, remember, mathematical functions are your best friend, meaning trigonometric functions, sine, cos, tan. um just be mindful of zero errors, meaning one upon anything. If you're using it, will lead to, if it's infinite or if it's zero, then it's very tricky. Sine, cos both have values which are zero. So if at any point you're doing one upon sine or cos, there will be at some point an error there. But the other values you could absolutely use. So let's see. Let's see. But I'm just letting you know some of the pitfalls. Okay, let's try doing a spiral of some kind, and then maybe we can do some layering, stuff like that. So now we're completely off the rails. Yeah, so if you have any ideas of what you want to do, let me know. We can try something. Or maybe we can start with a spiral and then, like, see what you want to do. Again, I have no direct idea how to do a spiral, but let's try. So let's keep this as a comment for now. Again, if you have any idea of what you kind of want to make, let me know. Please don't say any kind of direct fractal, because I have to import a lot of code, and I would rather like do something here directly, like that's completely us in a sense. But okay, so let's start with a basic spiral. For a spiral, I need the center, obviously. um, the center will be the size by 2. um, this should give me a size, actually. Okay, so now the center dot height and the center dot width um is my center. And okay, let's start with that. So how would we draw a spiral? So first of all, we would need to define a center point, right? Then we kind of go around. We kind of start with, let's say, at the center. We increase a distance over time, because we kind of need to add distance, and we need to change angles as well, right? So we increase the distance over time, and we increase the angles over time. So we would need two things, yeah. So let's say the distance is 0.0. The angle again is, again, we start at 0. Let's kind of, for now, just for the sake of readability, I'm not necessarily like efficient or like more like less code in a sense. I'm just doing it in a readable sense. We'll just use a while loop and simple deltas. So let's say every iteration we want to add some distance. um, let's call the distance delta 0.01. I have no clue as to how much it will be. uh, same, the angle will maybe need a bit more because we do need to show like a spiral. So but the thing is, these angles will be in radian, not in degrees. So 0.1 should be good, but I'm not sure. Oh, sorry, angle delta. And let's say we want to draw total points 100. So in a sense, I'm just trying to show you like how this works, and then we go to like, maybe we'll copy over that example from the code pen, and then we'll modify those things. So there, at that point, maybe you can follow along as well. Okay, um, so we'll just use a while loop. Um, Again, just using it for the readability, I can very easily use a for one here. But anyway, work code is less than total points. 0.1 is what, 18 degrees. Pi by 2 is 180. So pi by 2 is 1.6 ish. So 1.6 is 180. So 0.1 would be what? That is the question. Just divide that and let me know. Pi is 180. Yes, pi is not 360 because our mathematical system has failed us. So in radian, 2 pi actually is 360. So I have suffered a lot with this. In radian, pi radian is 180 degrees, not 360 degrees. So funnily enough, by the way, if you search for something called tau, TAU, uh, so tau is it has multiple things. Let's let go. But point is, tau is a symbol for 2 pi. So mathematicians really wanted to replace pi with 2 pi, because, like, by tau I mean, because pi is a really sad symbol. Yeah, so the thing is, like, tau actually covers the whole circle and it's easy to make calculations, whereas pi radian is only half the circle. But we're stuck with our definitions. So sorry, that is something that has caused me a lot of bugs over time, and it is something that is very annoying to me. Okay, so first of all, so we're drawing the points. Uh, so we still need to add distance. So we need to add distance delta to distance, and we need to add angle delta to angle. And while we do that, we'll also do the circle drawing. So how do we determine the X and Y position? That is the question. Okay, so what we'll do first is, we need what is the center. So center dot width and center dot height. So if we do that, first I'll let's just make sure for now it just paints everything at the center. Okay, very good. Now, actually, hang on, we will calculate it separately. X val. So we'll calculate X and Y val separately so you'll understand the logic better. Again, we got the center by just dividing the entire size by 2. So this is the actual center. And we'll just add this over here. Again, we've not calculated yet, so let's go with that. Y val. Now, how do we actually determine the whole thing? Assume there's, like, let's say there's a distance and there's an angle, right? So let's say the point is somewhere over here. So we can't actually use this polar coordinate system. I don't know if you can, but rather than that, like, what we need to do is we need to determine the X component and the Y component. So let's see, my math skills fail me one more time. So we need the distance into the cos component of that distance for the X projection, which will be the angle. And then for the thing, we would do sine angle. What happened here? Oh, need to import math. And hopefully, okay, we do have something of a spiral, but I seem to have um, I see what has happened. The distance being is the distance. Am I using it anywhere? Hmm. Or hang on, it shouldn't be. Yeah, okay, never mind. Multiplying for some dumb reason. Never mind. Hang on. Um, this should work fine, to be honest. Oh, maybe the distance is too little. Oh yeah, okay. So let's increase the distance delta then. Too much. Okay, so we're doing well. I would increase the angle delta a bit and decrease this a bit. Okay, so point is, so we have a spiral now, and funnily enough, like when you have something like this, you can do one of many things. So we have a working spiral now. The angle is fine. Distance delta, maybe I would shrink. And we'll add 300 points there. So now doesn't look that bad either already. Um, Point is, now we have a spiral. We've done that part. Now there's many things you could do. Okay, I'll tell you like the purposeful one and the accidental one. The purposeful one is that you could layer many of these, right? So instead of doing this per se, this is now a relatively self-contained function. So what we'll do is we'll take this whole thing and we'll move it to a different function. Let's say void draw spiral. Okay. Now we'll take the size, obviously, that's one thing, but we'll also take some other things. What we can also do, we can add a bit of randomness to it, meaning we can change the color, we can change the, oh, also we need the canvas, sorry. We need the canvas and the size, obviously, just to like draw. But apart from that, what we can kind of vary is these values. Let's the deltas. We can vary the what else can we vary? We can vary the color and the radius, right? So initially, let's just try to do that. Let's not do try too many things. And I was going to try something else, but okay. Initially, let's do this. Let's just like call this function, and uh, we can add some randomness to it, right? So okay, I know I can use a for function. Don't hate me for this. I'm just gonna do like 3 times, and now I'm gonna add some I'm gonna add some randomness to it. So first of all, just like so you have a random class, and then what you can do is, but you want randomness to stay relatively within limit. So let's say, and I think the random class only gives like next ints. So let's say we want a number 0 to 100, and then we'll divide that by 100. And here we'll divide that by 1000. See how that goes. I have no clue. So you see like a bit of randomness to it. At the same time, you see this overall, this starting out fine, but then this like randoming out a bit. Now, this is fine. This can still use a bit of work, obviously. Let's also define a list of colors. So you can also get some colors in it. If you have a favorite color, please let me know. Let's do Be purple. Let's do blue. Cyan. Maybe amber. We have red. Anything else I missed? Any good one? Yeah, greenish maybe. I missed one. I think amber kind of covers for it. Pink. Do orange now, man. Sadly, we don't have gold. I would be surprised if I had gold. Deep orange accent, okay. It's pretty reddish, okay. So we have, okay, let's stop. We have too many colors by this point. So for the colors, and I forget where my colors are, yeah. Since our randomness is before this, I'll just define this before. And what we'll do is colors dot, and so we'll get a color from the colors list, and we'll do a random with the maximum value of that list length. I'm hoping this works. Okay, not terrible. Okay, so you're now getting 3 lists with different colors, right? So it's still like, somewhat something off, right? So we've done the distance data and the angle data, but let's go with something else as well. So so I would say let's start with 2.0 and then add something to it, right? Let's do this thing. I have no clue how this is going to go. So point is, you can still see the randomness. You can still see some, and again, we're just starting with a very simple spiral, right? We're not doing something like that's extremely like, and you can find out the perfect spot. Again, I don't know these. I don't know any of this. It's just more like I'm finding the perfect spot for actually like doing this. And again, I understand it's still like, some things still aren't looking the absolute perfect they can look, but so this looks, this looks quite, I mean, it's still not bad art, right? I mean, compared to what I've painted before, quite good. So we have this. What else now can we vary is the better question, right? You can even without randoming, to be honest, sometimes what happens is like, even if we just stop doing this, right? Like if we did not random the deltas, you can still get some pretty pictures sometimes. Yeah. So as an example, you can still get some pretty pictures, because the thing is now colors are going to be overlaid with different sizes. So you can still get some like, nice pretty pictures. Again, not terrible at all. But with the randomness, you get some kind of thing. It looks slightly better. I like the slightly more messy kind of thing. Again, feel free to vary your deltas, feel free to vary all the other stuff. And now here's what I really like to change. Okay, so I'll tell you where the randomness and where the accidental discovery part comes in. See this cos and sine. This is where you really like to vary a lot of stuff, because this is what is determining the spiral shape. So maybe like, again, this may be absolutely nothing, or this may be absolutely everything. I just don't know. So let's say I add some cost to it. Look at that. Like, it's something that you would not expect. If now, just be mindful of your math formulae, which I know none of you focused on. If you do cos into tan, can anyone predict what will happen? It'll be a straight line. Why? Because tan is sine by cos. Cos will cut off. and it's both, and these both will be the exact same thing, which leads to a 45-degree line. So instead, you can just remove the cos and just do tan directly, and suddenly you have this weird mysterious shape, right? So you have these kinds of shapes emerging from this thing. And what if I really wanted to do something like, let's say I want to do, arc sine, maybe I want to do, maybe I just want to do sine as well. Again, now suddenly you get these conic shapes. You get these really lovely conic shapes without doing much. You started with a spiral, you did a bunch of these things, and again, what you could, I know. Okay, now actually let's use a for loop. I'm bored of copy pasting this. We can do this, and now you can realize that, okay, so this is kind of a bit weird. So what do we do? As in this, it looks good, but like the thing is the dots are a bit too big. So instead of that, we'll set a lower default size. We'll just crank this up a bit, but we'll also increase the randomness. Ooh, hang on, bit too much. Suddenly again, it's like a conic shape, and you've done quite a lot of, like, like, neat stuff to it. You can even like increase the dots and decrease the size. Suddenly again, this looks remarkably pretty. And this is something I like to do. Since this also depend on the distance, you can literally just add your distance, mix this distance into it, and usually something weird pops up. So it's like it's more random, but it's still somewhat related. Like you can sense that. So you can do like, sign like, you can do squares of angles, and suddenly you see like, more stuff in there. You can mix angles, you can add more stuff to it. So as an example, let's say this is cos and sine, you can do tan instead, and suddenly you see a whole new structure. You may also be able to do, you can even do tan squared. Again, just adding one function and so many things are changing like in amazing ways. Arc sine, a sine, what was it? This may lead to some problems. Yeah, complex reasons I don't want to go into right now. But overall, you can do a whole bunch of these. You can do one upon the angle, but now you have to make sure is the angle 0, right? So in that case, just initialize it as 0.01. So that kind of thing. So point is, this is not necessarily very interesting, but at the same time, you have these amazing shapes coming out of a literal spiral. And it is a beautiful thing to see when you just like, start out with something that's so simple, and by modifying these things which you have no idea. Again, I'm not sure why I'm doing this. It's just more like I know what things I can modify to get these pretty patterns. And yeah, and these things again, they come out, and you can vary these quite a bit. Again, like, you can start out with 0.5, you can add more iterations to it. Let's say you can actually um bit 40-ish. So you can do that. You can do, actually, hang on, you can do 35-ish. You get like bigger dots. You can, and this is, and here's another favorite thing of mine. Not only can you do this where you actually vary colors, you can also go into a state where you're varying the functions themselves. These functions themselves. So what you can do, instead of a color thing, you can actually make a list of functions. You literally go sine, cos, tan, atan, whatever. And you can now literally say, okay, grab any function. For what we did for colors, we could even do for this thing. but instead of the colors, we'll do functions. But we're essentially grabbing a function itself. Function we've grabbed, we still need to invoke it. And then I think close it off. Yeah. Look at this. Just random functions without we pulling out. And now you can, I think why they're still doing the same thing is because I have the same seed. But regardless of that, you can also do chained functions. So instead of doing functions, you can even do like a get function thing. You can, let's say I want 3 functions. You can mix sine, cos, and tan, and it will get you like an amazingly beautiful pattern. So since you've seen all of these now, you can actually go and see similar patterns in these as well. You can start seeing where that is coming from, right? All of these, we saw a similar pattern right now. Even this thing, that triangular thing, very similar thing right now. And even the spiral thing, this is very similar to that one. This is a direct implementation, this one, of the spiral. So and this one, it's actually directly, it's an actual spiral, but with the overlaid thing I showed you. And then with an extreme amount of randomness, you can get stuff like this. So point is, you can see how the basic principles we just explored go on to that. And yeah, that's the basic example. Ritvi, do we like, if we have time, we can go to the complex one. If we don't, yeah, it's been fun.
So time we do have. We will let the hackers poll whether they want to know more, whether they want to explore around, whether they want to play around, or I would say let's open it up for a quick Q&A if people have, because I mean I can totally see everyone's been totally mesmerized and been like no comments, and the number of people watching is very very surprising. So I can see everyone. I was sitting there just looking at the patterns change. So folks, if you are having any questions, feel free to either join the stream. You all know the drill to join the stream. And yeah, if you all want to continue, we can continue. I'm so glad you agree with me. So y'all again, if y'all want to join the stream and ask them any questions regarding any of what we discussed today or Flutter, feel free to do so. There's still so many people watching. I have a feeling they're just mesmerized and sitting there. So
Yeah, I mean, it's like, a lot of shapes just kind of come out with, I mean, it's just lovely because
it is. It is super amazing. I was just sitting there, completely mesmerized. Absolutely. Oh, they want to continue with this, learning more. Okay, great. Devin, do you have any blog regarding generative art just yet?
I do actually. I think I do. Yeah, I do.
Let me just quickly check the
So
calendar
it's
from
so
time
it's
purposes.
also like, so it goes along. So these are some of them. It describes essentially what I did for that as well. I could definitely improve the code snippets here, but the point is valid. Oh yeah, I also did animated versions of these. Again, the same process that we use right now, the same process we used is the exact same process in this one. So I actually made an animated version of this. It's and on my code pen, you'll find this, by the way. Let me mute it, by the way.
I love this reaction. All right, folks. So
On
here's
my code pen. Sorry,
just a
I'm sorry.
quick thing. So we do have a session right after this, so we can take another 15 minutes maybe. If you
Mm-hmm.
have something you can cover in 15 minutes, or what we can do is we can see if we can have another session with a little more complex designs in the next 2 days. I'll let Mary maybe have a poll for y'all to fill up if y'all want another session. Does that sound good? And I'll let Devin complete his
It's
explanation until
it's
y'all decide.
rendering way too many dots, but the point here is valid. You can go to my code pen and search for the animated trigonometric flutter, and you will see how it actually works. But funnily enough, it is very similar to what we just did. I just used recursion because I wanted to use at least one of my college concepts. And second thing is just some, like, just some other functions and stuff like that. And I'm using the distance. So I started using the distance as we were using right now, but I was using it here in a very slightly different way. But if you want to learn more about that, you can go and run like this. You can go through this blog post. One second. Or
I
you can
am
just find it on
sharing.
my.
I am sharing the blog post. Oops, why don't you all ask more questions? I'll be back in just 1 minute.
So you'll see this in my blog about generative art. But yeah, so there is an animated version of this because somebody pointed out like you could actually do an animated version of it. I was like, how would I do that exactly? So I realized I use recursion. I use recursion to kind of how do I do this? Kind of vary the delta as in the progression of each angle, and overall it turned out wonderfully. It's like a, it's almost like a, I don't know. I actually have a lot of animated things. Maybe let's see if I can show you some. I got some like prints for my new house. It was like really lovely. Let me see if I can do an animated version of it.
Do I get to show off my print as well? I actually have a print myself.
Oh yeah, I realize that now. These are my other experiments when just use the scaffold we learned about to make a 3D city, because why not? I
This
made
is
a
for
3D
you,
piano
Kevin.
tiles.
If you answered this, this is my print,
Sorry.
folks. Total flex here.
I made a black hole on a Flutter app and actually made it distort all the list items because, again, why not?
That
I
is the
made a
best question
gravity
you can
based
ask when you're
clock.
doing tech.
Gravity clock. I made a whole version on like gravity and like, wormholes, black holes, that kind of stuff. Um,
So we need to have a lot of sessions with you when it turns out, because there are people just asking more hows.
oh
So
yeah, this is another one of the generative versions, which actually looked pretty lovely. And what else? Oh yeah, even this one. There was like a magnetic field. Don't point out that it looks like a swastika. That was not intentional. There was some which actually progressed drawing, so you can actually see a line that draws something. Again, you saw how the discovery process was. It wasn't like engineered per se, but yeah,
there we
that was
go.
that. Oh, even this was lovely. Is a similar version of that for the first one, but you can actually see like a bunch of that. This was the original one. This was, yeah, I wasn't that impressed by this one. I love this one though. It was like an hourglass. The same thing. The hourglass that is, I think, on the thing right now. Yeah. You look at this shape. This is the same thing that I've animated and like prettier colors and black background, and you get this.
Wow.
It's like a planet and like, just like a very university vibes, right?
Very,
This was like
very,
a
especially
starry
with the
night.
colors and everything. If I end up posting Flutter generative art soon, it's going to be very yellow and very bright, and probably
When I was
epilepsy.
starting out, I think this was one of the first ones, and I was so impressed with this in the sense that I'm really not an artistic person. I understand why that might be weird, but I'm just not. And because of that, me creating this, not accidentally per se, but it's just more like, like I said, the discovery process is very much trial and error. So it feels like an accident, but in a sense that you have a general direction, and what comes out is really like, nature's doing in a sense. and just these kind of wonderful hourglassy type things even. So this actually came up when we were doing it right now, but like only half of it, so I overlaid a second design to do this as well. And yeah, I mean, it was pretty lovely. These were my first tries and my cat, but yeah.
Oh, amazing, folks! I'm gonna quickly compile all the links into one message and send it to y'all in case y'all want it again. And I can already see we'll probably be having a lot more sessions with Devan soon enough. Not like we're giving him a choice at this point. And Devan, that's totally a compliment in case you weren't sure.
Oh, thank you. Yeah, I can't figure it out very well. Oh, also just FYI, if you want to like, I like apart from generative art, I also do like a lot of sciencey stuff. So this is more of a planet simulator with a gravity and stuff like that. But the funny thing is, it uses pretty much the exact same logic, but with a lot more math. Because if you don't know, game development is just like 70-80% math.
This is such a lovely title to
This
your
is like
next
this
blog.
is nice. We should, right? I mean, that'll show the Android folks we're good.
All right, folks. This has been amazing. I think everyone here agrees. And we had an amazing turnout all through the stream, but surprisingly silent crowd, which I understand. But more questions for you then later, I guess. I'm not sure if Devian is on the Discord. I'm pretty sure he's not. So don't try to reach out to him there. There are other platforms that we've shared. Try and reach out to him on those platforms. And any other questions that we can quickly take before we close the session, or if there's any wisdom that you want to give out, Devin, final
No,
words.
there is no wisdom here as such, but it's just more like it's like the same thing, right? Like, as in, I'm not a very artistic person. I'm not good with color palettes, like, and there's a lot of stuff that I don't necessarily know. But at the same time, like, you can use these things, like, essentially you probably know code for your job, for college activities and stuff like that, and doing these kinds of stuff will redeem it. Like, it will kind of make you more interested, and like, it's much more fun. Like, it's something that you can't really have, like, a quantitative measure of how fun it is, or like how much you're gaining from it. But at the same time, like, you're going to end up a better coder because of this. But at the same time, that's not why you should do it. Like, just like, it's the joy of discovery in a sense. So yeah.
To answer the quick question, yes, you
With
can do.
JavaScript, yeah, I mean, everything. Look, anything that has a canvas, you can do it. But look, and even the Flutter canvas, we used one function, right? We used draw circle, and that's everything that we used in Flutter canvas. You could probably use, like, fancy Bezier curves, quadratic cubics, and whatever. You could use, complex paths and stuff like that. You could, but we use basically nothing. So anything with the canvas, you can do what we did. But if you want a more advanced implementation, I think somebody suggested 3.js. That's good. There's processing. Processing is heavily used for those kinds of things. Like, and you'll find processing implementations everywhere, as well as the original processing. But in a sense that I like Flutter mainly because I can run it. In the sense that I can actually compile it to a mobile app. Processing is not a framework, I think, but it's more of a it's more of a tool. So you can create something, but it's more that you can show the output. You can't compile the app or whatever. So that's why I prefer Flutter a bit. But again, anything that has a canvas, you can do it. But yeah, there's also specific ones that you can definitely use.
I think we've had this question a lot of times now.
What is Dartpad? So Dartpad is an online Flutter editor run by the official Flutter team, and you can run Dart and Flutter snippets in it, and it runs on the Flutter version of web. So because of that, you can do quite a lot of fun stuff with Dartpad because it runs on the web and it's a direct actual Flutter implementation. It's not some kind of, it's not some kind of emulated thing. It's an actual real world Flutter web thing. And they're also adding dependencies and such. So you can even import some things now. But yeah, it's getting better all the time. And for a quick tutorial, quick something you want to run through, or sometimes you just have a really bad PC in front of you, you can use it either way.
Awesome. Great. So we are, I think, good to go. We have another 15 minutes if you all want to just hang around before the next session starts. Also, Rosendo won't be happy with me saying that. So let's close this session. Uh, okay, keep the questions coming. If we don't have questions for a minute, I'll close the session then.
Generative art with Paint 3D. Okay, so 3D in a sense, the question here is what is 3D, right? I mean, look, you can make an impression of 3D, or you can have a rendering system that looks 3D. Sorry, that handles 3D, in the sense that I don't have my thing. Okay, but point is key. The idea is that you remember the hourglass thing that I showed you. It looked 3D, and even the velocities of the thing actually behaved like it was 3D, so it gave a depth feel. But if you actually want to deal with 3D, you can even make 2D look like 3D. In which case, you would have perspective. You would have to deal with a lot of other things. Then if you want to deal with real 3D, let's say with Unity and Unreal and stuff like that, what that does is it has actual knowledge of the 3D components of everything. So there are 3D systems in which you store all your variables, all your data related to every object in terms of a 3D world. And you have something that, or you use a 2D surface which has a perspective of 2D, of 3D. So I would suggest the second one if you're just trying to make art, like, just add perspective to it, add layering to it, and that kind of stuff. So that is what I would suggest. If you want to go through proper 3D art and actual 3D generation, I have not personally worked on it, so I can't comment on that.
Hi, Shavadeep. A little late to the stream, but welcome back anyway. So I hope that answered all your questions, folks. If there are any more questions, I'm going to wait another minute. If not, I'll close the stream because the next stream is scheduled to go live, which means there will be some glitch if we don't close it in zone. But I love the enthusiasm. I hope you all enjoyed it. We were here to have fun. I know I did. I was mostly passing comments, but I had fun. All right, I see no questions. So, Devin, you ready to say bye-bye?
Yes. Thanks for having me. It was lovely actually to see the enthusiasm of everybody, and like it was a rather specific topic, so I was kind of questioning to do, like, if I want to do it. But yeah, it was actually fun, and this actually worked out. I wasn't perfectly sure I would be able to draw a spiral without actually learning first, but okay, I'm like, that worked out pretty well. So yeah, we're good.
Great. I am looking forward to people tweeting about this because y'all haven't for some reason tweeted my previous sessions, which is very, very surprising and totally break of pattern. So do tweet about this. And because my profile is entirely your retweets, so I'm missing out on a lot here. But all
Give her
right,
a
folks.
life on Twitter, please.